So we have this question. This is the Regents prep for the scatter plots and line of best fit. So what is the correlation coefficient of the linear fit of the data shown below to the nearest hundredth? So we know that this line we know that the line, so if we wanted to draw the line, we know that the line will be somewhere over here. So that's what we have. So we don't have anything about the line, but we know a few things. So we know this is around the 7.5 point, maybe. This is around 9.5, right? So if we were to look at the slope, we know that it is negative, so that's a negative slope. So it's either 3 or 4. So we can get rid of these two options, right? So the slope, not slope, but slope, is negative, so it's one of these two. Now if we took these values from this line, if we took delta y, which is this value right here, the change in y, and divided change in x, which is right here, you can just use pure logic without mathematics. So 9 is greater than 7. Now if I did 7 divided by 7, I would get an exact 1, right? Now 9 divided by 7 is obviously greater than 1. So it should probably be answer choice 4 would be the best option. And you can also insert these values in the calculator, like all these coordinates that you have, and get the exact coefficient correlation using the procedure. So hi, for this video, for this question, August 2014, the table below shows the number of grams of carbohydrates X and the number of calories Y of 6 different foods. So we have that information right here. So what I'm going to do is I'm just going to use the calculator and use that to my advantage. So we know the procedure to enter these values. So the first thing we'll do is go to second, and down here there's a catalog, and then we'll select diagnostic. So we scroll down, we'll come to diagnostic on is what you need. There we are. So we'll hit enter, and then you'll see this on your screen, done. Okay, then we go to stat. So we need to choose edit, so I'm going to choose number 1, choice number 1, since it's over here. So I'll come to this entire screen. And then to clear the entire screen, I can just go up here and hit clear, my clear button. And then hit enter, and the entire screen clears. And now I'm going to enter all the values as I see. On the left hand side, I see 8, 9.5, 10, 6, 7, and 4. So let's put those. 8, 9.5, 10, 6, 7, 4. And then on the right hand side, I have all these 120, 138, 147, 88, 108, 62. So I have all these values, as you can see. Now the next thing that I need to do is go back to stat, go to calculate, and then choose linear regression AX plus B. I'll hit enter, I come to this screen, and then I go to calculate, and I see y is equal to ax plus b, right, at the top. So you see y is equal to ax plus b, where a is 14.11 and b is 5.83. Now there's only one option. Look at your options where a, so we want to see an equation of this sort, y is equal to ax plus b, and we get 14.11 x plus 5.8. There's a point over here. So there's just one option, answer choice 4. So in this question, there's a table right here, and then we are supposed to plot the residuals. We just have to mark these plots as we go along. And then we have, let's say this is 1 and then 2, and then -1 and -2. So let's mark our plots. 2, 2 is up here, 3, 1 is here, 3, -1 is here, 4, -2 is down here, 6, -3 would be down here, 7, -2 would be here, 8, -1, 9, 0, and 10, 3. So these are our plots. Using the plots, assess the fit of the line for the residuals and justify your answer. So what do we see over here? So our line of best fit could be somewhere over here, I feel, because it covers most of the points. So we have a line of best fit. What can we say? It has a positive slope or a positive correlation. Plus B, right? And is it strong or weak? I feel it's a weak positive correlation. So again, we've got this table to insert. So I'm going to put in all the values. I'm already at stat after doing diagnostic on. So let's put in the values. 186, 181, 176, 149, 184, 190, 158, 139. And then we go to the other side and we put in everything. 495, 477, 425, 322, 482, 587, 370, and then 322. Then after we are done with that, we can go to stat, go to calculate, go to linear regression, go to calculate once again, and then we get all the answers. So what's the correlation coefficient for the line of best fit? Round your answer to the nearest hundredth. So now since we have our values, our value for the correlation coefficient, is 0.942. And then they say, what does explain what the correlation coefficient suggests in the context of the problem. Now this is close to 1. Since R is close to 1, the correlation is strong. So strong positive correlation is what we'll write for this. All right. So in this question we have Beverly did a study this past spring using data she collected from a cafeteria. She recorded data weekly for ice cream sales and soda sales. Beverly found the line of best fit, which is right here. And the correlation coefficient, which is right here. As shown in the diagram. Given this information, which statement or statements can correctly be concluded? So eating more ice cream, which is right here, if you eat more, causes a person to become thirsty. So let's see if that's true. Let's take 2 points over here. If we take this value down here, and similarly let's use a different color. If we use look at this value, so the ice creams have increased, but what has happened to the cans of soda? It's decreased. So is this piece of information true? I think I'm gonna mark this as an X. Now similarly, drinking more soda causes a person to become more hungry. I think this is just the converse of the first statement. So let's check this. There is a strong correlation between ice cream sales and soda sales. So for this, we'll use this value. If this value of R is close to 1, close to the number 1, then the correlation is strong. Okay. So if it's close to 1, which in this case it is. So we'll mark 3 as our answer. So the correct answer would be answer choice 2. Alright, over here we have the residual plots from 2 different sets of bivariate data. Remember, bivariate data is relating to 2 quantities or 2 variables. And it's graphed below. Explain using evidence from graph A and graph B. Which graph indicates that the model for the data is a good fit? So graph A would be a good fit because it does not have a clear pattern, whereas graph B does. So if you look at graph B, it looks like a curve. So if we were to make a good fit, we could put a line somewhere here and we would have graph A points moving up and down. So the residuals would be above the line or below the line. So therefore graph A would be a good fit. So this is what I would write. Graph A is a good fit because it has points that are scattered. Sorry. Above and below the trend line. Alright, so we have this question. The table below shows the attendance at a museum in select years from 2007 to 2013, and the attendance at the museum is shown in the chart. State the linear regression equation represented by the data table when x is equal to 0. is used to represent the year 2007, and Y is used to represent the attendance. Round up all your values to the nearest hundredth. So we know a few things over here. They want us to write 2007 as 0. So let's put those in. And then 2008 as 1 and 2 and 3 and 4. This is how they want you to answer or enter the X values. And then the Y values are the attendance in millions. And they want you to round off to the nearest hundredth. Now we've done a few questions. Remember, this is how you write your numbers. So if you have something like this, let's say if these are the numbers, this 2 is the ones digit or the units digit, the 1 is the tens digit, the 3 is the hundreds digit, and then when you come here, you come to tenth, then you come to hundredth, and then you come to thousandth. So remember this idea whenever they want you to respond to questions like this. Now they need the nearest hundred, so they want till the second decimal space. All right, so this is what they want. Now again, if you recall how to solve questions of this sort, we had to use our calculator, and let's turn the calculator on. So let's put in this. So now we have this. Let's turn the calculator on. And again, we go to second right here and catalog to the bottom, and we get this entire menu. We need diagnostic on, so we'll keep going down till we get to diagnostic on. And that's when we'll start editing the file, the values. So diagnostic on, hit enter. So you got to done. And then you go to stat, right? And you choose edit. And let's clear all these. So you can go to L2 and hit clear, and then move your cursor and it clears everything. So hit clear, move your cursor, it clears everything. So let's put in the values for 2007, 2008, 2009, and so on. So we've got till 4. And then let's plug these in, 8.3, 8.5, 8.5, 8.8, 9.3. So we've got all these values. And then we'll go back to stat, we'll go to calculate, and then we go to linear regression, and then we go down to calculate, and we'll get our values for A and B, and that's how we'll find the equation. So our equation would be y is equal to ax plus b. So let's put that. Now what's the value of a? A is 0.23 and b is 8.22. So let's plug those in. So 0.23x plus 8.22. And they said round off to the nearest hundred. That's what I did over here. Okay, so this is your first answer. Then they say state the correlation coefficient to the nearest hundredth again. So what's our correlation coefficient? It's right here, 0.93. and determine whether the data suggests a strong or weak association. Now, this value is very close to 1. Strong correlation. That's your answer. So there's this and this. So for this question, whenever we are looking for a question of this sort, let's read it and then we'll see what we are trying to find out. After performing analyses on a set of data, Jackie examined the scatter plot of the residual values for each analysis. Which scatter plot indicates the best linear fit for the data? So whenever we are looking for a best line, we are looking for this. So a line and our point should be somewhere like around the line, maybe even on the line. So this is what we are trying to look for. So which graph out of all these is something like that, so that you have a line of best fit and the points are all in close proximity to it. Right here, answer 3. This is the best option. So whenever they ask for which scatter plot is the best linear fit, you're trying to look for a line of this sort. All right, so we have this. Erica, the manager at Stella Beans, collected data on the daily high temperature and revenue from coffee sales. Data from 9 days this past fall are shown in the table below. The high temperature and the coffee sales. State the linear regression function ft that estimates the day's coffee sales with a high temperature of T. Round all values to the nearest integer. Now, if you remember integers are any set of values that are like this: -3, -2, -1, 0, 1, 2, and so on. So let's go back to our calculator and insert values. So we'll turn our calculator on, we'll clear our screens, we'll go to stat because we've already put diagnostic on, and we'll clear all this. So hit clear, the clear button, and then move your cursor. So if you move your cursor, see L2 goes away. Then go to L1, go to clear, move your cursor, move this anywhere, and L1 clears. So let's plug in everything. So we've got 54, then we have 50, then 62, 67, 70, 58, 52, 46, 48, and then let's plug in everything on this end. So we got 2900, 30, 80, 2500, 2380, 2200, 2700, 3000, 3620, 3720. So we have all this. And then once we have this, we go back to stat and calculate and linear regression. And then to calculate right here. And now we got all our values. So we just plug in everything. We've got to round off everything to the nearest integer as stated. Okay, so keep that in mind. So let's go to the nearest integer and plug in all these values. So that's our solution right here. So y is equal to ax plus b. Let's plug that in. A is right here, b is right here, So we've got negative 58. We've got to round off to the nearest integer. So 58x plus 6182. That's our first equation, linear regression function ft. And we've got to write it in ft. So I'm going to replace this with ft. Sorry about that, but the color changed on me. So right there. So we've got ft as this equation. That's our first answer. So let's box that to show our first answer. Then we need the second part, which is the correlation coefficient over here. So it's showing you negative 0.94. Now this we've got to round off to the nearest hundredth. Does R indicate a strong linear relationship between the variables? Now numerically, this value is close to 1. Therefore, the relationship is strong, but it's negative. So, strong, negative correlation. So that's what we get. So let's solve this. The scatter plot below compares the number of bags of popcorn and the number of sodas. So popcorn is right here, soda is right here, sold at each performance of the circus over 1 week. So you've got these sales. Which conclusion can be drawn from the scatter plot? So we know that the line of best fit. So we can see a few things from here. We see that there is a positive line of best fit, which leads to a positive correlation. So it's choice number 2. Alright, the data table below shows the median diameter of grains of sand and the slope of the beach for 9 naturally occurring ocean beaches. So the median is up here, the x values, and the slope of beach in degrees is y. Write the linear regression equation for this set of data, rounding all values to the nearest thousandth. So now we are looking for the thousandth. Then they say, using this equation, predict the slope of a beach to the nearest tenth of a degree on a beach with grains of sand having a median diameter of 0.65. So first we'll find the equation, and then we'll plug in 0.65 for x, and we'll get our value. All right, so let's go. Let's go to the calculator once again, and let's plug in everything. So we've got this. Let's go to the calculator. Let's plug in all the values, clear this, go to stat, go to edit, clear all our values as we normally do, clear everything. And then let's plug in all the values. So 0.17, 0.19, 0.22, 0.235, 0.235, 0.3, 0.35, 0.42, 0.85, 0.63, 0.7, 0.82, 0.88, 1.15, 1.5, 4.4, 7.3, 11.3. So you got all these values. Then we go to stat, we go to calculate, we go to linear regression, we go to calculate, and we get these values. So that's our equation. So let's plug in all this stuff. So y is equal to ax plus b. We just plug in everything. We need it to the nearest thousandth. So 159, this value, will become 160, right? And b is negative, so I'm going to replace the positive b with the negative because that's what we have. And this will become 476, right? Because it's 59. So this is our equation. So that's our first answer. So I'm going to put that in a box. All right. Then they say use this equation, predict the slope of a beach to the nearest tenth of a degree on a beach with grains of sand. So what I'm going to do is I'll just use this y is equal to and plug the equation and then solve it myself, right? There are various ways you can plug in uh, the value of x, or you can use the equation and just use the table and get the values. So we need it at 0.65. So at 0.65 we get y is equal to 8.678 is the slope. So that's our answer. But we need it to the nearest tenth of a degree. So let's fix this. So let's not put this as the answer. Let's fix the answer. So we need it to the nearest tenth, as they are saying. So the nearest tenth would be y is equal to 8.7 degrees. That would be your answer. So let's read this question. Analysis of data from a statistical study shows a linear relationship in the data with a correlation coefficient of negative 0.524. Which statement best summarizes this result? So one way to get through with this question is we already know there's a negative right here. So let's read the options and see which ones we can use. So the first one, there is a strong positive correlation between the variables. Second one, there is a strong negative correlation between the variables. Third one, there is a moderate positive correlation between the variables. Fourth one, there is a moderate negative correlation between the variables. So we know that it's negative. So our answer should include negative and negative. So let's skip answer choice 1 and 3. And then we spoke about this idea prior to this question. Strong correlation means close to 1. Now this 0.5 is not close to 1. So it would be a moderate negative correlation. So answer choice 4. What type of relationship exists between the number of pages printed on a printer, the amount of ink used by that printer? So could you predict that? And if you could, how accurate could your prediction be? So could we say that amount of ink and number of pages, amount of ink in printer, the number of pages. What can we say about this? As you keep printing, as we print, So that means number of pages is increasing, right? What happens to the amount of ink? Does that increase or decrease? The ink in the printer decreases as you print more sheets. So this goes down. So one thing is going up, the other is going down. So a line will be like this. So does this have a negative or a positive correlation? This has a negative correlation. So it's either one of these two. The positive correlation is out. So let's check. Now, but not causal and causal. Those are the two words that are being used over here. Now we know that there could also be sheets where it's entirely like it has more grayscale or more black and white image. So our answer choice would be 4. So a student plotted the data from a sleep study as shown in the diagram. So average number of hours of sleep per day and age. So you guys fit in this category right here. So the student used the equation y is equal to negative 0.09x plus 9.24 to model the data. What does the rate of change represent in terms of these data? So the rate of change is right here, the slope. Slope is also rate of change. So we know the rate of change is 0.09. And we know it's negative, so it's a decreasing rate of change. So let's check. So answer choice 2. Bella recorded data and used her graphing calculator to find the equation for the line of best fit. She then used the correlation coefficient to determine the strength of the linear fit. Which correlation coefficient represents the strongest linear relationship? So for strong correlation, we want R, all of these values that we have are R, to be close to the digit 1, close to 1. So which two numbers are very close to 1? There's this and there's this. And we need positive. So positive, strong correlation. Which one is positive and close to 1? 0.9. So answer choice 1. So in this question, the results of a linear regression are shown below. So they've given us the equation and the values of a, b, r, and r squared. Which phrase best describes the relationship between x and y? So this value of r will help us determine the answer choice. So we know it's negative, and numerically this value is close to 1, so it's strong. So these are the two terms we are looking for. So 0.89 is close to 1 numerically. So we'll choose negative and strong. Let's find that. So strong negative correlation, answer choice 1. But let's just go through the other ones and we'll determine. So strong positive, no. Weak negative, no. Weak positive, no. Alright, this is an interesting question because it talks about Mountain Lakes High School. Are they talking about our school? The mathematics and physics scores of 9 students were compared as shown in the table below. So we've got the math and physics students. State the correlation coefficient to the nearest hundredth. So again, 2 decimal places. And then for the line of best fit for these data, explain what the correlation coefficient means with regard to the context of this situation. So let's plug in these values. and then we'll be able to predict what the correlation coefficient is. So again, we'll go to stat, edit, clear everything as we've learned previously. So now we have all these values. So we've got 15 at 5, 93, 89, 60, 90, 45, 64, 76, 89, and then we have 66, 89, 94, 52, 84, 56, 66, 73, and then 92. So you've got all these values, right? And then you've got linear regression, and then you've got calculate. So now you've got all these values. We need R. So let's put in the value of R. So we need the value of R. We see that on the screen, 0.9215. We need it to the nearest hundredth, so we'll write R as 0.92, right? So that's our value for R. Explain what this correlation coefficient means. So we know it's close to 1, so it's positive. We can see that. And it's strong because of it being close to 1. So this is what the correlation coefficient says or tells us. Because it's a high value, close to 1, we'll say it's strong, and then we see that it's got a positive sign. So hence positive. All right, we have this question. Omar has a piece of rope. He ties a knot in the rope and measures the new length of the rope. He then repeats this process several times. Some of the data collected are listed in the table below, a number of knots, and then the length of the rope. State to the nearest tenth the linear regression equation that approximates the length y of the rope after tying x knots. Then explain what the y-intercept means and explain what the slope means in the context of the problem. Okay? So let's get to our calculator. And let's start working. So we've got our calculator right here. So let's clear everything. Clear everything. And then let's put every value over here. 4, 5, 6, 7, 8, 64, 58, 49, 39, 31. And then we'll go to stat and calculate and linear regression, and then we'll go to calculate once again, and now we get all these values. So then we'll plug in our answers, and we need everything to the nearest tenth. So this question is already rounded off, which is excellent. It makes it easy. So y is equal to ax plus b. We'll take the values for a and b and plug them out here. So that's our first answer. Put it in a box. So what does the y-intercept mean? So the y-intercept is when x is 0. So if I put x as 0, I'll get y as 99.2. Now what does this mean? This means The initial length of the rope with 0 knots. With no knots. And then what does the slope mean? Negative 8.5. So this means that the length of the rope is decreasing by 8.5 every time you put a knot. So every knot decreases the length of the rope by 8.5 cm. So we have this question, the percentage of students scoring 85 or above or better on a mathematics final exam and an English final exam during a recent school year for 7 schools is shown in the table below. Write the linear regression equation for these data, rounding all values to the nearest hundredth. So hundredth means 2 decimal places. State the correlation coefficient. This is the value of R, which we'll get in a bit. And then you're rounding this even to the nearest hundredth and then explain the meaning of this value. So let's go to our calculator and we'll clear everything as needed from our list. So this is our calculator right here. Let's clear, go to stat, go to edit, go to clear everything. Go up here, clear everything. Okay, let's plug in all the values. So 27, 12, 13, 10, 30, 45, 20, then 46, 28, 45, 34, 56, 67, 42. And then we go to stat and calculate and linear regression, and then we get this, calculate. We get all these values. Once we get this, we can easily find the equation. We need y is equal to ax plus b, which eventually gives us 0.96x plus 23.95. Let's put it in a box. That's our answer. And then what's the value of r? R is right here, 0.92, again to the nearest hundred, so that's our value. What do we understand from here? We know it's positive and we know it's strong. So we have this question. The scatter plot below shows the relationship between the number of members in a family and the amount of the family's weekly grocery bill. So if I were to draw the line of best fit, probably it would be somewhere here. So let's say we drew this line as the line of best fit. So let's see what they are asking us. The most appropriate prediction of the grocery bill for a family that consists of 6 members, which is right here. So if we approach this to the graph, we are coming to this point, which would be somewhere at this point, right? So what should our answer choice be? So would it be 100, 300, 400, or 500? So our green line is between 200 and 300. So if our trend line moved up or down, we would be very close to 300. Sorry, we would be very close to 300. So I'm going to choose answer choice 2. Okay, so now we got this. The data given in the table below shows some of the results of a study comparing the height of a certain breed of dog based upon its mass. State the linear regression equation for these data where x is the mass and y is the height. Round your values to the nearest tenth. And then it says state the value of the correlation coefficient to the nearest tenth again and explain what it indicates. So let's go to our calculator and let's solve. So we'll pick this up, we'll clear everything, go to stat, go to edit, clear everything, and then plug in stuff. So 4.5, 5, 4, 3.5, 5.5, 5, 5, 4, 4, 6, 3.5, 5.5. And then let's plug in over here 41, 40, 35, 38, 43, 44, 37, 39, 42, 44, 31, 30. So we got all these values. And then we just go to stat, calculate linear regression, calculate, and we get all our values. So once we get this, we just plug in our responses. Y is equal to ax plus b. Y is equal to, we want the nearest tenth, so sorry. So let's plug in our values. 1.9x plus 29.8. This is our equation. And then for the correlation coefficient, we have the value of r right here. Even if we change it to the nearest tenth, we'll write it as 0.3. Now what do we see over here? We see two things. We see it's closer to 0, so it's a weak relation, but it's positive. So what this is saying is that the mass cannot predict the height. This is what this means. When you have a weak positive weak relationship, all you're saying is that this statement that the height and mass are related, right? That is not true. That is what this is saying. So the relationship between the height and the mass is not valid in this case. It's not a convincing relationship. All right, we have this question. The table below shows the number of hours 10 students spent studying for a test and their scores. So the analogy might be the more you study, the more you might score, right? And that might be true in most cases, but in some cases, what if it is not true? What if we have students who spend lesser time but still get a really decent grade? So you might get different cases. So let's see what's happening over here. Write the linear regression equation for this data set. Round off all your answers to the nearest hundredth. State the correlation coefficient and then round that off. and then explain what this suggests. So those are our questions. So let's go back to our calculator and plug in all these values, and we'll be nearly ready for this assignment. So let's plug this stuff. I'll paste it over here. I think we know the standardization of the question. So let's turn this on, clear everything. This is the previous question. So let's go here, let's clear everything. Let's go here, clear everything. Okay, let's plug all these values: 0, 1, 2, 4, 4, 4, 6, 6, 7, 8, and then 35, 40, 46, 65, 67, 70, 82, 88, 82, 95. So we have all these. Then we go to stat, go to calculate, go to linear regression, go to calculate at the bottom, and then we get our answers. So let's plug in our values. So y is equal to ax plus b. We want the answer to the nearest hundredth. So that would be 2 decimal places. So here and here. Okay, so we have y is equal to 7.79, which will round off to 80x plus 34.27. So that's our first answer. Then we want our correlation coefficient, which is down here, 0.98. And then we have our relationship. So we know it's close to 1, so it's strong. And we know it's positive, strong correlation. We have this question. Stephen collected data from a travel website. The data included a hotel's distance from Times Square in Manhattan and the cost of a room for 1 weekend night in August. A table containing these data appears below. So distance from Times Square in city blocks is X, and cost of a room in dollars. So if you go away from Times Square, your cost is going down. State the linear regression equation for this data set. Round all your values to the nearest hundredth. State the correlation coefficient for this data set, and then round it off to the nearest hundredth. Explain what the sign of the correlation coefficient suggests in the context of the problem. So we'll go back to our calculator. Clear everything. Okay, let's plug in all the values. 0, 0, 1, 1, 3, 4, 7, 11, 14, 19. And then on this side we'll have 293, 263, 244, 224, 185, 170, 219, 153, 136, and 111. Then we'll go back to stat, calculate linear regression, back to calculate. and we'll get our equation. So we've got y is equal to ax plus b. And they want us to round off to the nearest 100. So a is negative 38.23 and b is 629.10. So that's our first response or our first answer. State the correlation coefficient. That's right here. R is negative 0.39. And then they say explain what the sign of the correlation coefficient suggests in the context of the problem. So here we are saying that it's negative, so there is no correlation or opposite correlation, right? We are opposing the relationship that we want to define. So this is saying that the further you go away from time squared, your room rate is decreasing, right? But this, according to the answer that we are getting, we are not seeing that, okay? We are saying that as one thing is increasing, the other one is decreasing. That's what we are saying. Sorry. So yes, we are seeing what they want us to see. So we are seeing a graph like this with a negative slope like this. This is what we are seeing. Okay? So what does the sign show? It validates the data set that if we go away from times square, the room rate drops. So something of that nature, anything that describes the situation. So we are validating what is happening. Thank you.